As the need for an alternative energy source from the traditional fossil fuels grows as time goes on, nuclear fission could fill that void and serve as the future of energy for the world. Nuclear fission has tons of applications in the real world, whether it be from an atomic bomb or creating energy in things such as nuclear reactors. The basic process behind all these applications is the same, though. Nuclear fission is a type of nuclear reaction where a neutron is fired at a large nucleus, like that of uranium. The nucleus is split into two smaller nuclei and a large amount of energy is released. Uranium normally fissions into two nuclei with masses around 100 and 130 atomic mass units. When it fissions, it also releases many particles, such as alpha particles, beta particles, and stray neutrons. The kinetic energy of all of these particles is what causes the thermal energy produced by a nuclear reactor. These stray subatomic particles, mainly the neutrons, go and hit other uranium atoms and thus create a chain reaction that results in the fission of all of the fissionable material that's nearby. The energy produced in a fission reaction can be harnessed through an atomic bomb or through reactors, which create energy to power the world. So there are two main types of reactions that occur with the nucleus of an atom: fission and fusion. Fission, as we talked about, is when a big nucleus is split into two when it's hit by a neutron, and those two smaller nuclei also are produced alongside energy. And that results in a chain reaction with those other neutrons hitting the other big nuclei. A fusion reaction, on the other hand, involves two small nuclei coming together to form a slightly bigger nuclei, releasing a neutron as well and releasing quite a lot of energy. Although fission reactors exist today, fusion reactors do not, because fusion is a much harder process to induce than fission, because you're creating the bond between two nuclei, which requires a lot of energy to be inputted into the system. One common fusion reaction is the reaction between a hydrogen atom and a hydrogen atom with an extra neutron coming together to produce a neutron and a helium atom. This is a very common fusion reaction that produces a lot of energy and is actually the reaction that occurs in our sun. So a fusion reaction is actually what's responsible for creating all of the heat energy that emits from the sun. There are actually two types of fusion reactions that exist. The first type of fusion reaction is called cold fusion, and the second is hot fusion, which is actually just the type of fusion that occurs in the sun. Hot fusion occurs in stars and requires immense pressure and energy in order to actually react, which is why you need a particle accelerator in order to induce fusion. Cold fusion is a theorized idea that involves fusion at room temperature, and no experimental or theoretical method exists for cold fusion, so both of these are not viable for energy production.
In a nuclear reactor, a chain reaction is used to produce energy. After all, a single nucleus fissioning would not produce any significant amount of power. Uranium is purified and then made into rods. The uranium fuel rods undergo chain reactions when one atom is split by a neutron and the neutrons it gives off split other atoms. This continues until the reactor is shut off. Nuclear reactors are also very efficient. The fuel rods only use about 3% of the uranium present before being replaced, with all of the unused uranium being recycled. The power output also greatly exceeds the power input, unlike in nuclear fusion. Uranium does not emit greenhouse gases like many current power sources. A drastic decrease in fossil fuel emissions that would be caused by switching to nuclear power would greatly reduce the effects of climate change. The only major downside to nuclear power is that there is no good way to dispose of the nuclear waste that is produced. Much of it has been buried in the past, leading to the contamination of water supplies in some areas. Despite the drawbacks of nuclear power, it is still a good option for a future power source.
In today's world, nuclear reactors supply a whopping 14% of the worldwide energy. All of this energy comes from only 449 power plants, a minuscule number when compared to the 340,000 coal power plants. This is because nuclear energy is extremely efficient, despite the fact that current techniques only utilize 3% of fuel rods and the other 97% is recycled. The way that nuclear reactors work is like a coal reactor. The heat produced by fission of the radioactive metals is used to heat water, create steam, and spin a turbine, which produces energy. Unfortunately, the fission reactions of heavy metals do not continue endlessly. They eventually stop or slow. At a certain point, the enriched uranium rods used to produce heat are replaced with new ones, and the old ones are removed, split into spent and unspent resources, and the unspent materials are re-enriched to be used again as fuel rods. It is theoretically possible to make fission reactions renewable using plutonium-239. Plutonium-239 is produced normally in the burning of uranium-235, but in fast neutron reactors, the future of nuclear fission, the output of plutonium-239 can overcome the input, making it renewable. But fission is not likely the final form of nuclear energy. Fusion reactors are being designed and attempted in order to create an apparently endless source of energy. This source could solve the problems of the world because all you need for fuel is hydrogen, the most abundant element in the universe. Fusion reactors are ideal but likely won't be around for numerous years. But once they are developed, hydrogen can be easily harnessed through electrophoresis using just water and energy. But for the time being, fission reactors seem to be the future of energy. They are extremely efficient, produce very little amounts of pollution, and they take up very little space when compared to fossil fuels. The only apparent problem with nuclear fission reactors is the potential dangers of a nuclear meltdown, which are nearly eliminated in current reactors, and the only reasons they've ever happened is due to carelessness. Nations like France and Europe have fully employed nuclear fission reactors in order to maximize power output and have experienced no nuclear meltdowns in all of their history, which goes to show that nuclear fission, when used correctly, can be extremely effective and also very safe.